Okay. Okay. So can someone quickly brief about what we discussed yesterday? Can someone tell what we discussed, at least 1 or 2 points before we get started? Anyone?
Uh, Different types of triggers we discussed, like synchronous.
Great. Great. Okay. What else we discussed? Anyone? Yeah, thanks, Kiran. Yeah. Anyone else?
Uh, Hi, Surya.
Yeah, hi, Mahesh.
Yeah, we discussed about types like open, synchronous, closed, and push-based event types yesterday. Scheduled
Okay.
work, scheduled work.
Yeah, yeah, yeah. Are you guys able to like catch when we trigger a job from a developer point of view? Like whenever someone raises a request or commits or raise a pull request. So one of the use cases raising a pull request and triggering job is the most common use case that we do because we don't want to run a job based on every push. So yeah, so these are the scenarios that we discussed yesterday. Let me share my screen and share the agenda for today's class. So in today's class, like we will go deep into the multiple concepts on um, jobs. Gonna deep dive into jobs section, and also we gonna discuss we're gonna discuss about the steps section with practical demos, and also we have also called as need section to restrict a job to run based on the previous job. So we have the condition like needs. If some of you worked on Terraform, there is a section called depends on, where the resource gets created only the first one is created. If there are two resources, the second resource will create only the first one is created. Similarly, if there are two jobs, job one, job two. So in GitHub Actions, by default, to define two jobs. So these two jobs will run parallelly. But in real time, if say job one is a build job and job two is a deploy job, so we should only run the job one first and then job two. So you have to like tightly couple these, right? So in such a way that the job one should run first, job two should run second. So we do that using need section. So in the job two, you define a need section, needs job one. So you define like this in the workflow. So GitHub action will take this up and it will first trigger this job. It will run this job, and then once this job is completed, the second one will get uh, executed. So need section we will discuss in detail, which also called job dependencies we call. And then we're gonna discuss about users and then run. So users, you guys must be aware, we use users whenever you are trying to referring a custom action that is available from the marketplace. So you make use of the custom actions using user section and then run. So run you use inside a steps, which we're gonna discuss that. And then I'm also explain about working directory in GitHub Actions, and also I will talk about shell in GitHub Actions because most of the commands that we run inside a workflow, either it could be a shell command or it could be a PowerShell commands. So those I will teach you in detail in today's class. And then, of course, we also have some kind of concepts on timeouts and then error handling. So timeouts is like how long your job should run. Because if some job is waiting for an input from the user, so we don't want to keep that job for a long time, right? Because it will, on the back end, it will consume cost, it will consume the CPU memory, and it will also like based on the, if you, in case if your self-hosted runner is running on Kubernetes, you keep that job pod for a long time, obviously it will like the cost will increase. So if you use timeouts, you can set some timeout. So like for example, 30 minutes. So after 30 minutes, the job will automatically gets cancelled. So we'll discuss those in detail. And then also error handling. So in GitHub Actions, we have error handling concept. So where you use, for example, you are running a job and the job was failed. But so since the job is failed, but on the back end it doesn't affect the other jobs. Basically, whether it is succeeded or failure, so it will not affect the other jobs. So scenarios like uh, 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 in those scenarios, we basically use error handling. So we have like concept called continue on error keyword. You set this true, even if the job fails, it will continue, it will proceed with the next jobs. We will discuss that in detail that about error handling. So yeah, these are the agenda for today. Like anyone have any questions till now? Okay, so I'm taking that as no. Let's get started. So the first one is jobs. So as you already aware of the jobs, because we have ran some couple of scenarios and executed the jobs on the GitHub UI. So jobs are basically uh, jobs are basically you can consider as a series of steps. So in workflow, you can define multiple jobs, and inside each job, you define a series of steps that will basically run on the same runner. So each job can run on either the same runner or for like, let's say you have a job section in GitHub Action Workflow and you have a job called build job and you also have a job called deploy job. So you can run build on separate runner and also you can run deploy on separate runner. Or if you have only single runner, you can run build and deploy in single runner as well. So no restrictions with that. And inside jobs, GitHub will allow you to define multiple jobs inside your workflow, but there is some restrictions defining the jobs per workflow. For example, you created a one workflow, workflow.yml, and then you defined a job section. So by default, what GitHub have a setting is you can only define 256 jobs inside a single workflow. And inside that, you can run each job, like for example, you can define 256 job. So each job can have 255 steps. So this is a limit that was set by the GitHub Actions. And so right, like I was talking about the runners all the time, right? So in runners, we have different flavors, like we have Ubuntu, Windows, and also Mac OS. So jobs they can basically run on any of these operating systems, depending upon the definition that you define inside a workflow.yml. And so there is other thing that you guys should be aware of is job execution time. So for the job execution time, this is also a limit. For example, for the free GitHub accounts, so you can execute, you can run the job 6 hours per job, like which is around 360 minutes. So what does it mean, right? So whenever you trigger a job, So the job will basically run up to up to 6 hours. So scenarios like if you have a long running ETL process or backups, data processing jobs, so you can by default for the free accounts or even not only free accounts but also like pro accounts or enterprise accounts. So the default uh, job runtime is 6 hours. So there is a catch. So only this is applicable if you are running your jobs on the GitHub hosted runners. And whereas if you have your infra set up, if you have your runner set it up on self-hosted runners, there is no limit actually. So you can run as many minutes as you are depending upon the use case of our job. You can set that limit. You can run hours, like more than 6 hours. And this will be configured by the admin. So maybe obviously they will set up some limit, but you have a control over how many hours my job should run if you have your runners set it up on self-hosted runners. So, but for the GitHub hosted runners, so you have a restriction to run the job only for 6 hours. After that, after 6 hours, maybe it will either it gets failed or it will get cancelled. So similarly, like you might have heard about the life cycle of a pod or life cycle of an instance, EC2 instance. So similarly in GitHub Actions, we have a job states. Like this is not exactly a life cycle, but you can think of it, these are like states. Whether like for each job, we have a states like success, failure, cancel, and skip. So these are the job states we call it as. So why this matter is sometimes you run multiple jobs, you run 5 or 6 jobs for your application. And so you have a dependency that only if my job one is succeeded, then only the job two should run. So what you do in that case, you validate the job one status using success parameter, and then you pass it back to the second job and validate your condition using if. Using if you do the validation. Anyway, I'll show you the demo. Don't get confused, but just for the terminology point of view, just remember. So you have like in job states, you have success, failure, cancel, and skip. So success will like which indicates that all of your steps defined inside your job is completed successfully. That's the indication. And for the failure indication means if any steps fail or if there is any step that exited with non-zero exit code, either it could be a one or any number, which usually indicates that non-exit code. If it is zero, which means that it is a success one. It is exited with success. But if it is more than one or any other number, which means that it is a failure case scenario. And there is also called as cancel, where job was manually canceled by a user. Job can manually cancel by user. So if you manually go to GitHub and cancel the job, it will get cancelled. So there is also state called skipped, where job will not be executed due to some conditions, not met. So this is like we use scenarios like where if you want to deploy to higher environments and skip lower environments. So that time you can use this skip where you can evaluate some conditions. So based on the conditions, you can skip the job. So yeah, so without like this is like more theoretical, but let's jump on into the practical. So the first thing what we're gonna do is like we'll run a job. So let's create a repository and then give it a name like jobs steps repository name, and then let's keep it public, add a readme file, and then create a repository. So always like whenever the reason for I'm doing from the scratch is to get familiar with setting up the repository and then also getting familiar with the workflow folder structure. So for any workflow you write, so the default folder structure is .github /workflows/ any workflow name. Like now we are talking about the jobs. So you define jobs.yml. So and then you define all the workflow related steps here. So let's understand this. So you have a workflow name multi-job demonstration where it has a trigger type as on push, and this job will gets triggered only if the branch is main. If you push only to the main, then only it gets triggered. And then you have a job section. This is the one that we need to care about it. So in job section, you have a build job, you have a test job, you have a deploy job. So in the build job, you have the build job is running on Ubuntu latest, which is a GitHub hosted runner. And the test job is running on Ubuntu-latest. So the one thing that you need to remember is think I can, yeah, okay. Is it fine now? Is it fine now, Mahesh? Okay, okay. So in the job section, we have a build job and we have a test job and we have a deploy job. So in the build job, before this, right, let me show you this in visual video because in the UI it gets confusing. Let me show them in the Visual Studio. Yeah, okay. So this is gives clear idea. So you have a job name, multi-job demonstration, and then you have a trigger type called on push, which gets triggered only to make a commit to the main branch. And then inside a job section, you have a build job, test job, and the deploy job. So the build job is running on Ubuntu latest, and the test job is running on different runner. I mean, same runner, but it will create a new one. The deploy job will run on the runs on Ubuntu latest. So runs on is a keyword where you define uh, the runner that you want to run your jobs. So right now you don't have any dependencies in your workflow. That means GitHub will run these jobs parallel. Let's see this. Let's run this and observe the behavior of the runners. So I have added the change and then committing to the main directly because I'm testing on the main branch. So if we go to actions, so it started running the jobs. So you see, so 3 jobs started running parallelly. But some scenarios, I don't want to run jobs parallelly. I have to run the jobs one by one. So scenarios like that you have. So that's where we use concept called needs. So the first step is build job will get executed and the test job should run only if build is completed. So that's why I added a need section here. And then also for the deploy job should run only if once the test is completed. So I'm saving this. I don't want to save because I just want to copy this. And then I'm going to the workflow file.
Needs
then
means
paste.
is that a keyword, bro?
Yes, it's a keyword.
Okay.
It's like adding a job dependencies.
Yeah, got it. Thanks.
And then I'm committing it. So as soon as you commit, if you go to the actions and if you see this job, see it is running one by one. So first the build job is started running and then it started running the test job. So once that is test job is completed and then it is running the deploy job. So like the needs is like one of the important scenario based question interviews may ask. They may ask you to like how do you run jobs parallelly? How do you run jobs one by one? So if you can explain them, this is how you define it, like in the job dependencies section. So then you'll be able to answer them clearly, irrespective of the scenarios about the jobs. So the next one is
Where we check the output, Surya? Here.
okay, like so you have to go inside the job, and inside the job you see that steps section. So each step will give some kind of results. You see, so these are the results. Like this is example that I created. But so this example is basically printing the running test using echo. And you can think of this inside a job, these are the steps. So each step will have a different functionality. For example, you have this job where you should log into AWS and then download the S3 buckets. So the first step should be logging into AWS, and the next step should be downloading the S3 bucket artifacts, something like that. So jobs, inside jobs, you have a steps section. Like, does answer your question?
Okay. No, actually, my question is what? For suppose in normal process, what we will do in the CI, the Jenkins, first we have to download the code. The second step is what is the dependencies we have to install. The third step
Yeah.
is build the things. Then the next step is unit test case. Whatever the unit test cases is there, we have to run the things. The fifth one is we have to write the Docker file. Then once you are building the Docker file, we get the container image, and that image we have to upload to the ECR.
Okay.
Up to this part, the CI will complete. Am I correct? For this purpose, for suppose whenever we building the image, it will show the ECR. Then where we can means for maybe next examples, maybe you can explain. I hope like that.
Yeah. There are two things here, right? So let's remove this section and deploy. So whatever the use case that you defined, right? General use case in terms of checking out the code. This is the step you can think of. So
Okay.
what was the next step?
Build step. Okay.
So like think of it as a build step. Okay.
Yeah.
And what is the other step?
The second one is means the first one is the check out the code. The second step is the independent means dependencies we have to install, and the
Okay.
third one is yeah.
Let me install that. For example, dependencies, you can set up a node or download some dependencies. For instance, like just queue, like I'm just keeping as node. And then what was the third step? Building the Docker file, right?
First, build the solution. Yeah, I think.
The build will be part of, it's like if you're a micro-based application, your build will be part of our Docker file.
Okay.
Yeah. So before build and push, so you have to log into AWS, right? Am I correct or not? So, and then once you are logged in, so you have to define a step build Docker file. And then you do like steps like Docker build, and then you do Docker tag, and then Docker push. You don't need to remember these commands because we have a custom action to do that. Instead of running these commands manually, so you can use a section, and then you see it is automatically given. This is the custom action where you eliminate the manual steps section. So inside the custom action, you just define what was the context, file, and whether you want to push or like if you don't want to push, you set it as false. If you want to push your image to ECR, you set it as true. And you can also add a tag section. So this step will basically build your image and then push your
Yes.
image to the ECR. So this is the CI part. So you can run the CI part in
But
single
here
job.
in the means you want pushing the ECR means the credentials required. Am I correct?
Yeah, that's what you're logging here, right? So inside, once you log in, there is also one more step to log in into ECR.
Oh, yeah. And you mentioned the secret AWS access key ID. These values we can store in which place?
See here, secret section.
Secrets.
So
Okay.
you have a secret ID name, and then you copy that and go to settings. Go to settings, and you have a section called secrets and variables. Go to actions, and then go to repository secret, and then give the secret name and the value.
Okay.
Access key and case secret key. So during the job execution, so GitHub Actions will pull the secrets from the repository secrets that you created, and then it will log into AWS. So once you are like log into AWS, so you have to log into ECR, and then you can build and push your image to the ECR. This is a like CI part. You can run the CI part in single job, single runner. The prerequisites for this runner is, so AWS should install, AWS CLI should install, and you should also, the runner should also have a Docker running. So that's why there is a concept called Docker in Docker. So in Docker, what you do, so you have this runner. So this is a plain runner provided by GitHub. So in the plain runner, there won't be any Docker running, because you are executing these steps inside this runner, right? So when the step comes to build an image, so it requires a Docker to build your image. So in scenarios like that, you have to install Docker in Ubuntu-latest. Or if you are using a self-hosted runner, so the way you have to set up is, generally the self-hosted runners will run on EKS or Kubernetes clusters, where the runner runs as a pod. So you have to create a pod in such a way that Docker is running.
And how we know the things means if it is we can use the self-hosted or GitHub hosted, and how means who is telling and how we can know first of all.
We should propose to the project. Like it depends if this is a one or two projects that you are dealing, one or two microbase applications you are doing. You can like self-hosted runners, like it solves at some extent, but if you are like projects that are like so many applications that you are onboarding, so self-hosted is the best place where you can customize the runner behavior, where you can install the pre-installed softwares already. For example, AWS login or Trivi, you can install automatically, or SonarQube, right? You can install the prerequisites of software dependencies already in the runner. So the runner, whenever you start the job, that point into that self-hosted runner, it basically saves in time. You don't need to add the dependency steps here. Already the runner will have the Node.js setups
But
or any AWS
self-hosted
CLI.
self-hosted runner is more expensive compared to the GitHub hosted runner. Am I correct?
But like the thing is, GitHub runner will have a limitations.
Okay.
You cannot run your project jobs on GitHub runner. It is not secure, because you are putting your data on the GitHub infrastructure, right? And the traffic is going outside. So companies generally don't agree to run the jobs outside of the organization. So that's why even in my project, we use Kubernetes to run our jobs on the Kubernetes clusters. But anyway, we don't deal with the Kubernetes infra part, because my part is majorly on the CI/CD and the infrastructure creation. So that will be handled by a separate team. But in some projects, we do have to care about the setting up the self-hosted runners on the Kubernetes.
Okay.
Yeah. Okay, but by the way, that's a good question. Yeah, if you have any other question, we can discuss at the last.
Yeah, sure.
Yeah, thank you.
Hello, Anna. In coming classes, you will cover for every environment, we will create separate secrets, right? You will cover all these things, right?
Yeah. See, during
In
the
some
project,
projects.
project setup we do from the scratch. everything, environment, secrets, jobs, step. We also create a self-hosted runner on our own and install dependencies. We take a EC2 instance and make that EC2 instance as a runner. So all these things we do.
Yeah, thanks.
Yeah. So the default behavior that you might be understood right now. So if you run multiple jobs, so the default behavior of the GitHub action is it will run the jobs parallelly. So which indicates that like parallel execution, we call it as. So there are some benefits as well with the parallel jobs. For example, if you have a jobs that are independent and it has its own functionality. For example, if you are running unit tests, integration tests, or any kind of linting kind of check, like linting jobs where you will check the syntax of the code. So all these jobs are independently. We don't have to define a dependencies of the jobs. They can run individually. So scenarios like those you use parallel jobs execution where you will not use a need section. So need section you will not use if there are jobs are independent. And so one other important thing is right. So each job can run on different. I mean, in the sense, one job can run on Linux, and the other job can run on Windows, other job can run on Mac OS. So there's no restrictions for running your jobs. Let me show that an example as well. Just it gives you more on clarity what I was talking. So if you see my screen, this is a parallel job execution. So where you have the trigger on push. So this will trigger a job whether you are pushing to a main or if you are pushing a feature branch or any branch. So you just make a commit, it will trigger the job. And you have a job section where you have a job unit test that runs on Ubuntu. So this job will completely dedicated to the unit tests. And you also have another job called integration test, where this job functionality is to run the integration test. And you have another job as linting. So technically, so these jobs can run independently. So you don't have to write like you don't have to write need section and then add integration test. So you don't have to define like this. You don't have to wait until the job is completed. So if you know that if you don't have dependencies, you don't have to use need section. So you can run these jobs independently. So if you copy this, then go to GitHub Actions. Let me open. Yeah, go to GitHub Actions and edit the workflow.yml file. I'm just copy pasting. I'm not doing anything fancy. So I'm just making a commit. And if you go to job section, so action section, so you can see these jobs are started running. And you see this check marks that these jobs are running individually. So you don't have any dependencies. We are not using any need sections. So unit test case will run parallelly, integration test will run parallelly, code linting will run parallelly. So understand in the real time, right? Whatever the unit test, integration test, code test, whatever the runs it is running, it will always produce a result of it. So you can either attach that result you can send that result via mail, or you can add the result to the job summary. So right, this is the summary page. So whatever the result, whatever the output of this unit test, you can add to the job summary. So where it will display at the bottom. Right now, this is an example, that's why you're not able to see. But whether like the number of test cases passed, failed, so those numbers you can see in the job summary itself. That's how we need to set up for the developers so that whenever they trigger a job, they can see everything on the UI. Even for the SonarQube analysis report as well, we should show them in the summary page. Not just every detail of it, but just how many passed, how many failed. So that kind of scenarios. Even if you are scanning Docker images, so those reports you should add to the job summary. I'll also show that during our projects, how you can add the output of a job as a summary, like how you can add the job output as to the summary, so that we can show. But for now, understand that summary is like overall summary of your jobs and their outputs. And since we are discussing about the jobs that can run parallelly, so you can run in jobs independently depending upon the use cases. If you think that all of the jobs don't have any dependencies, you can run them parallelly. That's the whole idea. So the next thing is so needs section. I think needs. I think I talked about in detail when we should use, where exactly you should use. So I'll just show that again. So you have to define the needs section at the job level. So like here you have to define. So under job, so wherever you have job, under above or below you have to set. So you should not define this need section inside a steps. It will not go inside a steps, but you have to define this section inside at the job level. You call it as a job level. So next one is the user section. So users and okay, this users we talked, like this is like steps we fixed, steps we missed it. So let's discuss the steps sorry, my bad. Should be users only. Users and run we can discuss now. So let's go to the before the demo, just understand a little bit about the user section. So I have shown you like when we use user section. So you basically use this when you are referring a custom action. So you can simply add a user section and then refer to the custom action. Either you can refer to your own custom action or you can refer the marketplace custom actions. And there is also one more thing called, so whenever you are using a custom action, so under user section, you have a called as with. So with is basically you define it to pass the parameters. You can pass the parameters like you can pass something like build ID, for example, one. So you can pass these inputs to the custom actions. So custom actions, whether you are writing your own custom action or if you are using a marketplace custom action, if you are using marketplace custom actions, so the marketplace custom action will be already defined what parameters we should pass to the custom action. So with section we basically use to pass the inputs parameters. And then we are like inside the job, inside the steps. So you have a section called run. So run is basically you define all the required steps. You use like basically if you want to copy a file, the Linux using Linux command, you can use copy. So run basically helps us to support the commands that you want to perform inside a job. So let me show you an example, then you can understand even better. So right now, if you see, so this is my workflow where my workflow name starts with steps documentation and the trigger type is on push. So I have a job section where I have a job called demonstrate steps. And then if you go, so you have a step section. So these steps will runs on Ubuntu. And so each step will define its own uh, functionality. For example, so the first step will basically check out the code. So where does this run? Where does this step will perform? This step will perform on this runner? You just have to make. So the hierarchy will go, the flow will go is first jobs and then steps. And inside steps, you can have multiple steps. And then you are setting up the Python using the setup Python action. And then you are running few commands using run section. So run is basically where during the automations you write some of the steps that you tend to be write manually. For example, if we want to create a directory or copy files or create a directory, so sometimes you may not be required to create a custom action for that. So scenarios like that, you use run sections. But if there is already a custom action available, you use uses section. And then during the uses section, you are also passing the Python version 3.10, which means that it will set up the Python version 3.10 to this custom action. You are telling indirectly. But if you are running using run, you can run the series of commands inside this. But if you are having only single command, for example, if you have a single command like this, so you don't have to use pipe. You can straight away define like this. But if you think if you have more than one command, then you can define like this. So you use pipe symbol and then you define under the pipe symbol. You can define more than one command inside it. So like this. So you can define another command like this, another command like this. So it will keep on. If you think that there are so many commands, you can write like this way. So run will have multiple commands that you can define inside it. So and then I also have another step called where it will create a directory and then it will create a file and then it will list a file. So these are the Linux command where I'm performing. Again, these are all performing on this runner. So I'm making use of run section to run these commands on the runner. And then finally I have another step. So what this step does, it will first print the error message and then it will do some kind of loop over the shell directory. So basically you can run the Linux command, everything inside the run section. All these will be performed on the Ubuntu. So you make use of these concepts using uses run to complete your task. So other thing I want to show you is working directory and shell. So working directory, I think whenever you are running some step, whenever you are running a job or step, so you can define the working directory where you want to, for example, if you have a folder called scripts folder. So inside the script folder, you have a script called download.sh, and you also a script file called upload.sh, and then download or copy.sh. So these are all the scripts that I have in the scripts folder. So during your job execution or whenever you're performing any jobs or steps, you can define your working directory. So which you are directly telling to the steps section or job section that, so my working directory for this step is scripts. So inside the scripts, you run download.sh. So for this specific step, what was the working directory you are passing? You are passing the scripts working directory, and then you are directly running the /download.sh. So GitHub, what it will do, it will not look, you don't have to manually define the path. For example, if it is like if you're having a scripts folder on home, Ubuntu, on this directory. So you don't have to manually go inside this directory first. And then once you go inside the directory, inside the directory, you don't have to run the script file manually. So instead of get rid of all these manual steps, what you are telling to GitHub Actions. So my working directory, my scripts are all in the scripts folder. So that's why I'm defining my working directory as scripts folder. And then once you have the scripts folder pointing at the step level, so you can simply run directly the download.sh. So what it does, it will directly look your download.sh file on the script folder. So you can also think this as a working directory in the sense like whenever this step is performed, you should always go and look my script in the script folder. So that's the functionality, powerful functionality of using work directory. So in GitHub Actions, so the default working directory of a runner is slash runner slash and then the root. So this will be the directory, and you can also, you don't need to manually define this directory. You have a keyword that is supported by GitHub is github.workspace. So if you define this keyword, so GitHub will automatically display your, it'll consider that you need, like you want to point out your working directory. So I'll show that this in, let me show that in the demo. I mean in a job. So I'm asking Copilot, create a workflow to display workspace directory. I need to give specifics in the sense like create a workflow to display directly using github.workspace. So you see now it provided github.workspace. So let's, instead of manual run, I'm just making this as on push. So I have added all these triggers, doesn't matter because you have this on push trigger. So anyway, it will trigger your job. So let's go to the workflow. Go to workflow file, need this file. Copy paste this and then, so maybe there is like some syntax errors, you see, yeah. So now it's good. If you run, commit, and go to actions. So you see the job is started. And if you see, if you go inside the job, we'll have all the steps. So you see, this is like waiting for the runner. So if the runner is started, the first step is checkout. And the second step is list files in the workspace. So you see, right, ls-la, then you see github.workspace runner path. So the default path like is home, runner, and then work, and then followed by the repository name. So it will follow like the repository name twice. So it will print list the files inside your repository. That's what it done, right? So you have inside this repository, you have only readme file, and then you have a .github file. So what happening in the background is whenever you execute a steps, all these steps will be performed on the runner. So obviously the runner is nothing but a virtual machine. So inside the virtual machine, we'll have so many directories. So this is one of the directory that that will be created by the GitHub itself, GitHub Actions itself. So in this directory, the code will be checked out. So you have checked out code, right? Whenever you try to check out our code, so it will by default check out in this directory. So once the code is checked out, you are trying to list the files in this folder. So that's why you are able to see these files, which is nothing but our source code. We basically download this source code on the runner. So this is like super useful during your projects. Like you deal with multiple automations. So you deal with the folder structures. For example, if you want to run a script, sometimes the script might fail and then you need to debug the folder, like where this exactly the repository is cloned. So there are like multiple scenarios that you encounter during the real times. So that's why knowing the folder structure of the runner is very important. And then So the other thing that I want to show you is about, I want to talk about is shell. So I was talking about from the starting. So the default shell is like a bash. So where for the bash, it will support Linux and Mac OS. So, so whenever you are running or defining the steps, you define the shell as bash. And if it is a PowerShell based project, and if you are running PowerShell commands on Windows machines, so you define the shell command as pwsh, which indicates that which this means that PowerShell. So this like is a platform only the Windows commands can able to execute. And then each shell will have like as you might know, so different Linux will have a different commands, and PowerShell will Windows commands will be little different. And yeah, so these will be shown anyway. Let me show that in the demo so that it will be easy for you. Yeah, so let me show that the Visual Studio. Okay, so if you see this, so I have the workflow that's starting with the workflow name, working directory and shell. So the trigger type is on push. So now you have a job section. So you have a job name called directory and demo, where you define the name as directory example, and this job is running on Ubuntu latest. So for this job, the first step is where it is checking out the code, and then it creating a folder for project structure using a run section where you define multiple commands. So where it will first created using mkdir, it will create a directories, these directories, and then you are trying to add some content to these files. So greater than symbol will basically create a file, which we discussed in the last session. And then you see this step section is also having a working directory. The working directory is /frontend, which you created in the previous step. So the working directory you set it up this, and then you are trying to list the files inside this working directory. And then you also have another steps called working directory as a backend, where you're also listing some files. And then here comes, you have another step as well, which is shell. So if you are not defining any shell step here, by default, we take bash. So for this session, for this step, so I have intentionally defined the shell as bash. So there is also another shell called PowerShell, which is if you are running shell as PowerShell. See, GitHub Copilot is automatically suggesting to change that to Linux, I mean to Windows. So if you define the shell as PowerShell and if you run these commands, it will fail. So you have to define as bash, and if you are running the Linux commands. You can also change the shell based on the use case. If you are a shell command, you should use this. So, but it will even fail because your runner is Linux. Ubuntu-latest is a Linux flavor. So you have to change that to Windows-latest, which means that whatever the shell commands you have here, these will be executed on the Windows machine, which is like kind of compatibilities issues you have to solve. So I have also called another job called Windows Shell job, where this time the job runs on Ubuntu latest runner. So inside that, if you see, you have a shell section called PowerShell, where you are running few shell commands, and you also have a shell command CMD, where you are running some commands just to list directory. So command also is one kind of a shell you can define, where you can use Windows command prompt, right? You know, you guys must be aware of Windows command prompt. So that is exactly the CMD stands for. But for the PowerShell, it is like a PowerShell terminal. So in Windows, you have two terminals, right? You have a command prompt and you also have a PowerShell. So PowerShell is like a cross platform, we call it as, where you can execute, like where it is even powerful than command prompt. So CMD is like just a normal Windows command prompt where you're just listing the directory. So let's change this back to Ubuntu-latest because all of my steps are written in the Linux. So, and then change this as well to bash, and then copy this and go to the job section. And then paste it here, and then commit and see how it behaves. So if you go to actions, the job is started. See, anyway, this doesn't matter. These jobs are running parallelly. So the first job is a Linux job. How do you find whether it's a job is Linux or Ubuntu? You have to go to setup job section. So if you go to the setup job section, here you see like which operating system it is used. It is used Ubuntu. And similarly, if you go to the Windows shell example, you have to first thing, like if you want to find the job it is used, you go to operating system. It is basically used Windows Server 2025. So this is how you can run jobs on multiple platforms like in Linux and Windows, which is like GitHub Actions will support the platform, cross-platform kind of style of running your jobs on multiple platforms. So the other thing I have is like timeouts and error handling. So yeah, so like the timeouts and error handlings, these are also you define either in the step level. But most of the times you define these as step levels. So timeouts, as I was talking in the beginning of the class, timeouts you set it up at a step level where you define till what time your job should run. And then for the error handling, so one of the error handling, you mostly deal with the continue or continue on error section. And so for the timeout side, so you define mostly like I was telling that either you can define at the step level or job level. So the default timeout for a job is 360 minutes. So for step levels, earlier it was supported like timeout section by GitHub Actions. So now that was removed. So you have to use your own custom logic to set up the timeout section if you want to set up the timeout at the step level. And this timeout will start when job begins. And if once if the timeout time is over, which means that it indicates that job is failed. So these are like the theoretical, and even for the error handling. So for the error handling, the first thing that you need to know is like continue on error, which means that whether if the job is failed, if you want to even continue, you have to set is continue on error is true. If the job is failed, by default, the continue on error will be set as false. So that time it will not proceed running the other jobs. So, and also there is a section called conditional execution, which is kind of where you can control the jobs using if condition, if success, or there is also have a condition called if failure. There is also condition called if always. And one more thing you need to understand is if you can also fail the job manually using exit one inside your step section. So one thing that you need to understand is success means like a job is completed successfully with exit code as 0. So other than 0, all other job status is like failure, considered as failure. And always is kind of you can set this like at the job level, which means that you run the job always irrespective of the previous job, whether it's failure or not. So in Jenkins we have a similar section called always section where you write this step at the last end of the Jenkins file. So similarly you have a section called if, where you can run jobs even if something is not happened or failed. So this if always section we use mostly scenarios like if you want to do some kind of cleanups. So scenarios like that you use. And so yeah, let's move on to the demo for this as well. Then I'll take up your questions. So yeah, so these are like the workflow where it has the workflow name as error handling and timeouts, where it has an on push trigger, where you have a job section with the job name timeout demo, and this job is runs on Ubuntu latest. You see there is a section called timeout. So I have set the timeout as 2 minutes, which means that this job will run, but once after 2 minutes, the job will automatically fail. If you want to increase the timeout, you can also increase the timeout to 20. So as I was talking in the theoretical, so the default timeout, if you don't specify this timeout, the default time the job will run is 360 minutes. But you can set the control over like 10 minutes, or depending upon the use case, you can define the timeout. So using the timeout minutes parameter. This right now have defined at the job level. And so there is also a step section where you have one step where you have a sleep section. So where it will wait for like 120 seconds, it will be on sleep. This step will be in sleep mode. And then you also have another job called error handling, where it runs on Ubuntu latest. So here you need to observe, right? You have a step section. So this step section have a command called exit one, which I'm intentionally making this step as failure. But even that is failure, I'm also intentionally making this step as success. So the continue on error indicates that even this step is fail, this whole step will consider as success, and the whole job will consider as success. Anyway, we will run this, no need to worry. And then we also have a step called if failure. And this runs only if something is failed, the previous step is failed, this step will run. And this step will run only if something is succeeded. And this step will always run. And then you also have another job called failure handling. So where you have a logic that have set this logic might fail, but since they have set it as continue on error, this will mark as success. So let's not care about that, because all of the concepts that theoretically we discussed, we have this in the first job itself. So let's copy this and go to GitHub Actions. And then edit the workflow.yml file and edit these workflow steps, and then add this workflow and then commit the changes. So let's see how it behaves. So I committed, and then the job is started triggering. So we have like two jobs running. One is the timeout job, and then is error handling job. So the timeout job will have a series of steps. It's executed. See, since you have set it the timeout, so it will like, and also you have set the sleep as 120. So it will like be in hung stage for 120 seconds. And then obviously it is like it will fail after 2 minutes. So that's what timeout we set it up. Where error handling, we don't have any timeouts or anything as such. But you see this, you have a step section, see? So you have a intentionally making this step as fail, and you have also got an error. Since you have defined continue error, this step marked as success. So let me check that as well. Let me remove the continue on error statement. So if you go and remove the continue on error statement here, where it is, see this one. Either you can remove or you can comment. Let's comment this. So let's comment this. So I commented this. So like theoretically what should happen? It should fail the step, right? So let's comment this and go to GitHub Actions. So if you go inside this job, and so our we have made a change on the error handling step, right? Continuous, see, now it's failed. And eventually this step is failed. But earlier it was not failed because you have set the continue on error as true. So if you are not specifying anything, the default continue on error parameter is false. That's why the job is failed. It is not perform these jobs. But what other job is performed is conditional execution or failure. So this job is performed on because the previous job is failed. So these are like little concepts. When you do actual practicing of each concept, then you'll get clarity. But so these are the concepts that super useful. Most of the projects in the whenever someone writes GitHub action workflow, they definitely write these steps depending upon their use case. Most of this like everything like the use of this continuous or error is like again depends on the use case. We don't define this on all the use cases. And these also condition if conditions you define at a step level. So you also use this depending on the scenarios only. But you need to really understand these are like exist in the GitHub Actions. So whenever the scenario comes, you need to pick up these and then use this. And let's check the previous job. What is the status? Because it was in hung stage. I think it is completed, which means that we are able to exit successfully because you have set the sleep as and also the timeout as 2 minutes, which matches. That's why it is succeeded. If you increase the sleep timeout and if you set the timeout as 2 minutes, then this step will fail. So you can maybe you can try this out in your whenever you get time. Yeah, I think that's it I have for today's session. Anyone have any questions? Mahesh, Ram, Kiran, you have any questions?
I think so. I will check and I will come back if anything.
Okay, perfect. Yeah, guys, thanks a lot for joining the session. Please practice each concept so that it will be easy to like you don't need to mug up anything. Right now, like only thing you need to remember is the concept part because coding part anyway the AI agents is giving. So you just make those, I mean, whatever the AI is created, just make those functional. As simple as that. If you want to make those functional, you need to understand the concept. That's the whole idea. Not just GitHub Actions, even any other tool is either it could be a Terraform or any other Kubernetes YAML files. So you just need to aware of the concept. Yeah.
Oh yeah. Hi, Sunil. Hello.
Yeah, Mahesh. Yeah.
Yeah,
Yeah.
actually, in my previous interviews, in 1 or 2 interviews, when I kept GitHub in resume, they expected GitHub Actions and GitHub admin like experience also.
Yeah.
So they're expecting that also. Like from your side, any basics for GitHub admin?
I have
Or
shared the documentation if I'm not wrong. GitHub admin documentation I have shared.
Means they are expecting to take care of the admin and this GitHub CI/CD total.
Okay, like I have the document, GitHub administration doc. You can go through that. I'll share
Okay.
that again. I'll share that again. Maybe I'll share now in the group.
Okay.
You can go through that GitHub admin. It is a like a useful document. It is given by the GitHub itself. It was not prepared by individuals. I have that document. You can go through that. Yeah. Yeah. So interviews these days they're asking actions. Obviously, that's the whole idea because everyone is transitioning into GitHub Actions.
Yeah, actually they are expecting like in one of interviews they want like I want to migrate from GitHub Actions to GitLab. They are asking from other Jenkins to GitHub Actions like that. They are expecting they need to migrate from other platform to like GitHub Actions.
Yeah, like
My,
yeah, I got it. Like I have worked on migration project of pipelines where I migrated from Jenkins, Bamboo, GitLab, Azure DevOps to GitHub Actions. So GitHub will provide a tool called Action Importer. Can I share my screen again? If you guys have time,
Yeah,
you guys have time?
You can
Yeah,
share.
okay. So so there is a tool that GitHub itself will provide called Action Importer. So this is like a migration tool. So where you can migrate, see, this is a useful documentation. where you can migrate with GitHub Action. So and the tool they use is Actions Importer. So here you can like these are the supported CI tools. Currently the Action Importer supports where you can migrate from Azure DevOps, Bamboo, Bitbucket, Circle CI, GitLab, Jenkins, and Travis CI. So the prerequisites is you have to install your Docker on your machine and also GitHub CLI. Once that is installed, so GitHub CLI will have the commands like GH, where you install the action importer tool on your machine. Once you install that action importer, you just have to configure that. It'll ask you for a couple of options. You just have to define. And GitHub Action Importer will have a commands where you can have like it has a commands like audit, forecast, dry run, and migrate. So audit will basically audit your entire instance of the Jenkins, Bamboo, like how many Jenkins files are there, everything it will validate. And dry run will give you the actual output, the migrated output. If you run GitHub migrate, it will migrate your source files, either it could be Jenkins or GitLab to GitHub Actions. So in GitHub Actions, it will create a PR of whatever the migration is done. So you can go through this documentation and you can try it on your local machine. I'll share this link in the chat. During interviews, you can tell this. So this is how I have done migration. They'll get they'll get impressed to tell this. Does that make sense?
Definitely.
So I have posted that in the group. Like I'll also share the documentation. Someone asked the admin one. Let me share that as well. So we have everything. Just we need to start going through. Yeah. Are you guys see the document I just uploaded? Yeah. Can you guys see now?
And Surya, like going forward, you'll cover each concept this today you cover like jobs, needs, users, and going forward you'll cover like variables and
Yeah.
secrets, and later you will
Yes.
integrate everything into one
Correct.
project from scratch.
Yes. 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 That's the whole idea.
Okay. Like apart from only this integration, integrating with like other Terraform, like with GitHub Actions, like those use cases also you'll cover.
Yeah. Terraform we have, and integration with Docker, Kubernetes also we have.
And nowadays they are mostly focusing on security only. This
Yeah. We can
in
just.
this LDAP is used in GitHub Actions also. In the Jenkins it will be they use that.
The
I
like
don't.
SSO, LDAP also we use in the GitHub as well, but that is we use at the enterprise level, not on the cloud level, because in reality, all of the GitHub accounts are at the enterprise level only, because all of the users, they'll have multiple users, right? Using the public hosted GitHub is not a good practice because enterprise users will have their own client IDs. For example, I'm working as a Google, my ID will have surya@google.com. So if you log in that using public GitHub, it is not a best practice. So they will create an enterprise account. In the enterprise account, they'll enable the LDAP single sign-on, and then they will use their own IDs. That will come
So,
everything under admin part.
So from
Not
our side, we don't do anything. That LDAP security thing is taken by like other teams or other party. Or like
yeah, yes. But interviews you should not tell that. In interviews
yeah,
you should tell that you have
because
done that. Yeah.
in previous interview they asked, I don't know LDAP at that time. After that, I got to know like it is taken by security team only. But they asked like how you do LDAP process and how you integrate in some Jenkins. Yeah, they asked. So I don't know at that time.
At least 1 or 2 points you should tell uh, instead of you got right what I meant.
Yeah, I know. Yeah.
Interview is all about a trick.
Mm.
So every
Because
question is.
they will come to know some, as you said, like within 5 to 10 minutes, they'll come to know whether we are
Yeah,
like
yeah.
hands on.
Even I have, I'll take interviews for my company. Some of them will like, they'll tell answers like as their experience, but some of them will like, they'll like tend to be that they worked, but that we will be easily get to know whether he's really worked or not.
Like
But
from your side,
hmm,
after the end of the course, any like mock interviews will conduct.
yeah,
Like,
if yeah, we can take. If you
it
have,
will be yeah, it will be helpful.
sure. We can connect if anyone of you like, you can book some time with me, and then you can ping me, and then we can connect, and then I'll take mock interviews.
Yeah, from your experience, even other tools, how they will ask, like you can tell.
Yeah, sure.
Yeah, thank you, Surya.
Thanks, Mahesh. Kiran, Rama, do you have any questions?
No, sorry. Yeah.
Okay. Okay, then. I think we can wrap.